All right, so 9.7, we are changing how we're using sine, cosine, tangent. Okay, all along, we've used sine, cosine, tangent in the right triangle. And that's what sine, cosine, tangent are, right? They are in a right triangle, the relationship between the sides. As you get older in math and you go into algebra 2 and beyond, you're going to talk about sinusoidal waves and a lot of different things with sine and cosine and tangent, other than what we've talked about so far. This is our intro into it, right? That's why it's just part of geometry here. But you'll realize that sine, cosine, tangent do a lot more than what we've shown. Okay. Today we are expanding slightly into that because we are now going to be solving triangles that are not right triangles. Okay, we're going to be solving any type of triangle. And remember, by solving, we mean finding the missing side lengths, the angle measures, all of that. So we're going to be dealing with acute, we're going to be dealing with obtuse, we're going to be all over the place. But what that means, since we are dealing now with obtuse angles, we are going to see, we are going to use the calculator to find the sine of 100 degrees. Even though that doesn't make sense to us in terms of a right triangle, right? We're going to trust that that's what we need to do here and trust the calculator to give us that amount. So I want you to go ahead and type in sine 100. Let's find sine 100. Let's make sure we got that. What is sine 100? 0.92. Sure. How about tangent of 120? Tangent of 120. Yeah, so now we get into negatives here too, right? Which doesn't make sense to us in terms of that right triangle, but since it's an obtuse angle, okay, we can't be thinking in terms of that triangle anymore. Once we start typing in obtuse angles, we have to realize it's not the same thing anymore. Okay, and just we got to go with it. All right. So what we're going to do first, besides just typing in those values and getting numbers, which you already know how to do. Okay, so we're not going to spend any more time on that. Is we're going to be able to find the area of a triangle without knowing the height. Okay, so we're going to be able to find the area of a triangle without knowing the height, without having that altitude piece, or without even having to find the altitude. We can do that by using sine. Sure they can see it here. All three of these formulas represent the same thing. You don't need to write all three of them down. Okay, you can write one of them down, but put the picture as well. Because the picture and the formula have to go together so we know exactly what it is that we're talking about. So I'll give you a second. Let's get that down. I'll tell you, this is not on the orange sheet. Okay, so you need to know this. So once you write that formula down, circle it, star it, highlight it, do whatever you need to. You are going to have to study and know this. And that's going to be true for all the stuff that we do today. All right, so taking a look at this, we've got our area formula. I'm going to use this one just because it's closest to the picture. And they're all the same. What they're telling us is the area of this triangle is 1/2 times 2 of the sides multiplied together and the sine of the included angle. So you got to know that relationship, right? How that fits in. That angle is the included angle between these two sides. Just like here, this angle is the included angle between these two sides. A is the included angle between BC. Okay, so we have to realize that when we go to solve it, when we go to set up our equation, plug in numbers. So it would be A and B, those two sides, and the included angle. Okay. So when we see problems like this, and again, we can solve for any type of triangle now. Let's say this is 100 degrees, this is 6, and this is 7. We can find the area of this triangle just knowing that information. Now, once you go ahead and plug that into our equation, let's round it to the nearest 10. So we should be able to just type that right into the calculator, right? All at once. We don't need to do sine 100 and round it or anything. I would just type that entire thing right in. What do we end up with here? Less than
20.7.
Yeah, about 20.7. Okay, you just got to make sure that you're using the included angle between the two sides that you know. Now, when that's all they give you, of course, that's pretty obvious. Okay. But when they instead give you, all right, this is 30, this is 40, find the area. Well, now we got to realize that we need that included angle. So these are the two sides we have. We need the included angle, triangle sum theorem. Then we can get that. Now we can use that. Okay. You have to have the setup correct before you can find the area. Just be aware of that. Okay. Your mistakes are going to be when you're using the wrong angle or a wrong side. Okay. All right. Questions on that? Finding the area. Okay. Again, hopefully that is circled or starred or something. You got to know that equation. You got to be able to use it. Okay. We don't see it very often, but you will see it. You will see it on the test. All right. Let's move on. So the next thing that we're going to look at is solving triangles, right? We're going to solve this triangle. Okay, we're not going to do it right now, but this is the type of thing that we're looking at. It's not a right triangle. You cannot use Pythagorean theorem to find C because it's not a right triangle. We can't use our basic sine, cosine, tan, any of it, right? All the stuff that we've dealt with in chapter 9 so far has been only right triangles. So we got to do something different. Okay, yeah. Pythagorean inequality theorem could tell us what type of triangle, but we can't use that to find a side, right? Because there's an inequality sign in it. We could say, you know, what C has to be less than, something like that, but we can't find the actual value. Yeah.
Is there such thing as a hypotenuse of a non-rectangle?
There is not. No, there's a longest side, but it's not considered a hypotenuse. Yeah. All right, so what we're going to do here is we're going to use what's called the law of sines. The law of sines. Okay, so I'm going to give you a minute here, a minute or two. I want you to copy this down. The picture and then these proportions. Okay, the picture and those proportions. And I do want both of them because they are slightly different. And we're going to refer to both of them here. So if you haven't yet, give you a minute and I'll start talking. Okay, so first thing to notice, and I might have mentioned it yesterday, I know I did in a couple classes. Notice we've got the same letter multiple times here. You got a capital A, you got a lowercase a. The capital letters are always the vertices, right? The angles. And then the lowercase letters always represent the sides. And even more than that, they represent the side that's opposite that angle that has the same letter. So lowercase a is the side across from capital A. Lowercase b is the side across from capital B. So that has to be the case when we're looking at this formula. And we have to realize that. So when we see a lowercase a and a capital A, we need to know that those are across from each other. So what we're looking at here is a proportion, right? It's fractions with an equal sign, it's a proportion. And this is telling us that the ratio of the side length and the sine of the opposite angle is always going to be equal in any triangle. So if I know the side length and the sine, or the side length and the angle measure, I can do side divided by sine of that angle, side divided by sine of that angle, it's going to be equal. Sine or side divided by sine of that angle is going to be equal. In every single triangle, this proportion will hold true. And since this proportion will hold true in every triangle, we can use that to then solve those triangles that we haven't been able to solve before. So we take a look at that one that I showed a little bit earlier right here. And we're looking here, we need to solve for the rest of our stuff here, our angles, our sides. We need to be able to set up that proportion. So to be able to set up that proportion, we always need one pair, one of those fractions we need to know already. Okay, so what you're looking for is you're looking for one angle and the opposite side that we know both of. Okay, not that there's a variable for, but that we actually know the value. So that's going to be A and its opposite side. Okay, so we have that information here. We have that combination. Now we're going to use what other information they gave us to be able to solve for something. Right? If I'm trying to find C, I can't solve for C because I don't know this angle. Right? If you don't know either of them, you can't set it up, you can't solve it yet. I know this is 11, so that means I'm going to be solving for angle B next. All right? Because that's the next one that I'm looking at. It's always got to go across from it, right? So when I set this up, I'm always going to put what I'm trying to solve for on the top of my fraction. That's just going to make it easier. It doesn't have to be, but that's why they gave you the two versions of those proportions. Because sometimes we're going to put the side length on top, sometimes we're going to put the angle on top. Whatever we're trying to solve for, let's put that on top. So I'm going to try to solve for that angle. So I'm looking at sine of B over 11. I got sine of that angle that I'm looking for over the opposite side. I'm going to do the same thing with the ones that I know. So I would write sine 115 over 20. I know the one up above, right? Where we see the law of sines there, it shows all three. I'm using this one. It shows all three. We don't use all three at the same time. We're just going to use two of them. Okay? You can't solve something with two equal signs. So we're just going to use the two of them here. Any questions about the setup of this? Okay, we'll have plenty of practice getting that set up. So we're here, now we got to solve for that angle measure. Okay, we got to solve for that angle measure, which means we got to get that angle by itself. So I could cross multiply because it is a proportion, right? I could cross multiply, but then I'm going to have to divide by this 20 again anyway. So instead, what we're going to do to solve this, I've got sine B divided by 11. I'm going to multiply by 11. I'm going to multiply both sides by 11. That's gonna get that sine B by itself. And then over here, that 11, multiply it on the top, not the bottom, just the top. So that's gonna give me 11 times the sine of 115 over 20. And we've talked all along about how we don't want to round, right? We don't want to type in sine 115, get a number, and then have to round it. We're going to let the calculator do all the work at the end at the same time. So we're just going to rearrange stuff until we get that angle by itself. Then we're going to use that calculator. Okay, so we multiply both sides by 11, that cancels this one out. I get 11 sine 115 over 20. How am I going to find that angle? So this is what we talked about yesterday. Well,
Sin -1.
yeah, we're gonna use that inverse of sine. Okay, that inverse sine. So what that does for us, is if we do the inverse sine of this whole thing, that's gonna give us angle B. So angle B is going to be equal to the inverse sine of 11 sine 115 over 20. Why don't you go ahead and type that in? Inverse sine of 11 sine 115 over 20. A lot of stuff to type in the calculator, so we got to make sure we do it correctly. Talk to somebody about it. See if they got the same thing. Okay, so that's a lot to type in, right? One thing that we got to make sure of when we type that in, and we end up with 29.9 as our answer. Well, one thing that we got to make sure of when we go to type that in, yeah, inverse sine, it opens up a set of parentheses, that's fine. We got 11, you don't need multiplication, so just 11 sine 115. But when you type in sine, that opens up a set of parentheses. You need to close that set of parentheses around the 115. If you don't close the parentheses around the 115, it's going to take the sine of 115 divided by 20. Okay, so we need to close that parentheses, then divide it by 20. We don't need to close the parentheses at the very end. We could, it's not going to change anything. And then we can get that 29.9. Okay. So it's a lot of stuff to type in. We got to make sure that we do it correctly because the calculator is only going to do what we tell it to. Okay. So we get about 29.9 here. How are we going to find angle C? Triangle something, right? 180 minus 115 minus 29.9. That's going to get us this angle. I don't know what that is. 35.1. Okay, 35.1. Now that I have that, okay, this is another one of those cases where we don't like to do it, but we have to. We have to use our answers to solve another part. So now that we have that 35.1, now we can set up something with C. All right, I want you to talk to the person next to you. How are you going to solve for side C here? What are you going to set up to solve for side C? Just set it up and then we'll talk about how to solve. Okay, what are you going to set up here? it's set up to be able to solve this. Remember, we need those two ratios. That we're gonna do. Tyler?
C over sin 35.1 and then 20 over sine.
There you go. And remember, whatever I'm trying to solve for, I'm gonna put that on top. It just makes it a little bit easier. Okay? So now I'm solving for a side length, so I'm gonna put C over sine of the opposite angle. And then again, I'm using that one combination that I already know. The 20 and the sine 115. Any questions on that setup? Now we're using that second set where the side is on top. It really doesn't matter which one you use. It's just easier when what you're trying to solve for is on top. So here, I have divided by sine 35.1. So I'm going to multiply both sides by that. And when I multiply both sides, that just comes up top here. So what I'm looking at is that. And I'm not using inverse sine anymore because it's just C is equal to that whole thing. So and on my calculator, I'm just doing 20 sine 35.1. Make sure you close that parentheses, divided by sine 115, and that'll get us our answer. Go ahead, type that in, let's make sure. So you should get us about 12.7. See, it's, yeah, there's not a lot of triangles out there that have whole number angles and whole number sides. It's one or the other. You're either gonna get whole number angles or whole number sides. You're really not gonna get both. Sometimes neither. Okay, questions on that? That's the big idea here, is that law of sine. Okay, again, that's what it's called, law of sine, where we're just setting up that proportion and we are solving. All right, so here we go with a different situation, right? They give us a different combination of values and information. We're looking for angle A, side A, and side C. Once you go ahead, take some time, you can talk to each other about it. Okay, but I want you to find those three values. you haven't yet, talk to somebody. They're doing the same thing.
And then what?
All right, here we go. So angle A is the easy one to find here. Triangle sum theorem, we have 48 degrees. Okay, we got that. We're gonna have to use that to find A. Side A. Okay, to find side C, you got it set up here. C over sine 107 equal 15 over sine 25. Multiply by that sine 107. We type that into the calculator, we get our answer. What is C going to give us here? Lesson
33.9.
33.9. Okay. Good. And then A, same exact thing with the 15 over sine 25, but now it's A over sine 48. We type that in. What do we end up with, Sophie? 26.4. There you go. Okay. Any questions on this? Okay. There is just one more setup. We're not actually going to solve this. I just want to look at it and talk about the setup or how we would go about it. I know it's a little tough to see with the color in here. But they give us a 71 here, 60 here, and 150 here. So right now, we don't have any pairs that match up, right? We don't have a side and an angle. We can easily get there though. Triangle sum theorem, we can get there, we can get angle B. So we would have to do that first. Because to be able to use law of sine, you have to have one combination. You have to have a side and the opposite angle. If you don't have that, we cannot use law of sines, and then we get into what we're talking about on Monday. Okay, so you have to have the side and the opposite angle. So once we know this angle, now we can set up that proportion to solve for the opposite sides. Okay. All right. Any questions about our law of sines? Make sure we know law of sines. Again, that's not on the orange sheet. Okay, you have to know that heading into the test next week. Okay, go ahead.